Hey everyone, my name is Maike. I'm a postdoctoral researcher at the University of Potsdam in Germany, and I am really excited to talk at the second instantiation of the Furhat Conference today because at Uppsala University, where I did my PhD, we were really one of the very early adopters of the Furhat robots. To this day, the Uppsala Social Robotics Lab has one of the oldest robots of the Furhat that's still around. And I can really say that without this robot, my PhD research would have not been possible in that way. So I'm very, very excited to share some of the insights from my PhD research, but also beyond that with you today. I know that we are already quite late in the conference day, and the theme of this conference is interactions with robots. So we've probably already heard a lot about the how of interactions. How can we teach robots to be interactive? How does good human-robot interaction look like? I want to take a step back and I want to ask the question of why. Why do we care so much about the interactivity of robots? Does it really matter? And how much does it matter compared to how the robot looks like, for example? So I know that we are at the Furhat Robotics Conference. So when I ask you to think about a robot, the result might not really be representative of the general public. So let's imagine we are going to the streets and we are asking a random person on the street to just think about about robots and tell us the first robot that comes to their mind. So a lot of them may mention a vacuum cleaning robot or a lawn mowing robot because that's a type of robot a lot of people already have around in their own home. So in America, for example, around 22% of people say that they have or had a robot in their home environment, or at least they may know people. So it's quite a bit of people who have or had like very close experience with one of these robots. They may also talk about Google Home or Amazon Alexa devices, and even though they are technically not really robots, it's still something that comes to people's mind, again because they are around quite a bit already. Another robot they may come up with could be from science fiction, either from movies or from books. They may also think about one of the robots that is more of an entertainment robot, for example, here the Sony Aibo robot, or one of the robots that is talked about in the news quite a lot, or that is sent around on viral YouTube videos, like the one from Boston Dynamics. And what all of them have in common really is that people have either interacted with them themselves or they have seen or experienced them probably in interactive scenarios, like the Wall-E robot, for example, that is interacting a lot in the movie, or even the robot from Boston Dynamics that has some interactivity with other robots or sometimes a human in the videos. Another robot that may come to people's mind, but is quite a bit different from what I've talked about so far, is a Geminoid robot. That is one of these types of robots that is very, very human-like and is made to resemble a real human being as closely as possible. What's different about this type of robot is that a lot of people may have heard about it or may have seen a picture, but not a lot of people have actually met one or seen it really in interaction. But when we think about research, that's actually one of the types of robots that we research a lot. And the reason for this is the famous Uncanny Valley. The Uncanny Valley is a theory originally proposed by the Japanese researcher Masahiro Mori in the 1970s. And his theory was that when you make a robot more and more human-like, up to a certain point, people like it better. Their affinity to it grows. So for example, when you have an industrial robot, people tend to not really care about it much. They find it neither very likable nor very unlikable. When you make a robot more and more human-like and come, for example, to the Pepper robot, then people's affinity tend to grow quite a bit. They like being around it. However, when you come to these overly human-like robots that are almost human-like but still a bit off, so they don't exactly look or move like a real human, then people's affinity tend to drop quite a bit. So suddenly they don't find it likable anymore, but they start finding it uncanny or eerie, and that's what we call the Uncanny Valley. And these types of robots is what is cared a lot about in research. So this phenomenon of the Uncanny Valley, since it was originally proposed by Mori, was picked up in a lot of research experiments where people try to look into, does this phenomenon really exist? So I started my PhD with looking into this research, and what I found was that in most of these research experiments, people use just robot images or robot videos. So in only very few of these experiments, people actually met a real robot. That means that the perception that we know a lot about is the perception of still images or videos, but not really interactive scenarios. And when it comes to how long people were actually exposed to these robots, it's really quite short. For the robot images, all of them were below 1 minute of exposure, most of them much, much shorter. The same holds for robot videos, where only very few of them were longer than a minute. And for the cold present robot, it looks a tiny bit better, but still most of them below 15 minutes, which if we think about human-human encounters is really, really short. And obviously with images and videos, you can't really have interactivity. But even with the cold present robots, not all of these experiments were interactive. There were some where people were still asked to just look at the robot, or where the robot was basically just around. So why does that matter? So what we've seen is that when people think about robots, they think about robots that they probably have often already interacted with, or they've at least seen interacting somehow. But in research, what we have really only researched so far are first impressions, and mostly not even first impressions of interactive robots. But when we think about our long-term goal, what we really want is we want to have robots around in our everyday lives, in our homes, in our workplaces. That's really where we are aiming to go to. So the question then really is, how much do these first impressions really matter? And can we learn something from these first impressions that matter for these long-term interactions? So what I started with was the question, so if we take just one interactive encounter that people have with a robot, how much does people's perception change over the course of this interaction? What we implemented was a very simple interactive scenario, the 20 questions game. In this game, people come and think about a character, any kind of character, and then the robot asks a bunch of yes and no questions and tries to then guess the character people are thinking about. It's a very simple game, and it was embedded in an experiment where people first came and looked at the robot wouldn't do anything, and we asked them how they perceived the robot. Then the robot would introduce itself, just non-interactively, would just talk for 2 minutes about itself, just showing them a bit of what it can do. And then we asked them again what they thought about the robot, how they perceived it. And then they played the game with the robot. And after this interaction, we asked them again about their perception. And what we found was that it really matters that people see the robot in action. We see for the anthropomorphism, for the warmth and competence, that people's perception of the robot increased when it actually started moving and doing something, and even more when they actually had this interactive experience with it. And for the discomfort, we saw that people got way more comfortable with it as soon as it actually started doing something. And that's really, really important, because it means that what we research in just as very first still impressions might not really be representative of what people think about the robot when it starts doing something, or they can even interact with it. So then I started thinking, okay, so if we can already alter people's perception of robots just within one course of an interaction, how about if we ask people to interact with the robot multiple times? How would that change the perception? And this time we made a bit of a more complicated interactive scenario, because one thing that people said about the previous one was that it was a little bit simplistic. Even though it was interactive, they didn't have much of a chance to really interact with the robot. So we tried to create an interactive scenario that gave them a bit more chances to both get to know the robot in more of a social chat scenario, but then also play a game that's a bit more complex and allows for more interactions. And what we created is what we call RDG-Map. It's a geographically themed game, and the idea is that people play together with the robot in a team and they learn something about the world map. This is how participants would view the experimental scene. They would see a world map both in between them and the robot, and then they also had a private map that was shown to them on a tablet to their right, as you can see here. On this tablet, they would see one country highlighted as a target country. And their aim was to describe this to the robot so the robot could select the same country. They could describe it in any means. They can say the name of the country, the shape, where it is located, and the robot tries to find it on the world map. And if it would find it, it would mark it on the map that is located in between the two so that people know what the robot selected. I will give you now a very short excerpt that you have an idea of how this game interaction actually looks like.
To the east of India and north of Australia.
Got it.
You got it.
Is it this one?
Yep, that's the one. Good job.
Nice.
So, should we take the next one?
Yes. Let's move on.
Alright, you remember where India was?
Yes.
So this country is bordering to India to the west of it.
Is it this one?
Yes, that's the one.
Yay!
Good.
Before you get too excited, let me say that this interaction that you just saw was completely remote controlled. We decided for this experiment to go for a remote controlled approach because we didn't want people's perception to be lowered by too many just misunderstandings of the robot. So in this case, it was fully remote controlled. We are, however, currently working on an autonomous version of this exact game interaction and will try to replicate our study with a more autonomous version of the robot. Our results were in the same line of what we've seen with a study that we did just over one interactive scenario. We've seen that some of the perceptual dimensions like competence and warmth, people can judge already pretty well after just a social chat. So in this case, what we labeled here as first impression is a quick 2-minute social chat interaction. And here people can judge the competence and warmth already pretty well. When it comes to anthropomorphism, so how human-like they perceive the robot, then we can see that this is still increasing after the first game interaction, but then it remains stable over the second and third time. If it comes to likability, that still increases from the first to the second interaction and only then stabilizes. And even more interesting, we've seen that the dimensions more related to the uncanny, so threat and discomfort, actually decreased all the way up to the third game interaction, so the end of our experiment. So this really shows that it also matters to not just look at one interactive encounter, but really look at the long-term and repeated effects of having people interact with the robot multiple times. Then the last question we asked ourselves, so can we maybe even influence this process? And now we tried to create different personalities. Again, we are looking at the same game, the same geographical game. And now the robot was either an optimistic robot that was very encouraging. So when they would miss a point, it would say something like, don't get discouraged, let's focus on this next question. Or it was more of a challenger. It got frustrated easily because it really, really wanted to score points. So it would say something like, human, come on. Why are you taking such a long time? Do you not want to win? You see here that it's really quite different what the robot would say. And for the very first time, these exact utterances were not authored by us researchers, but we actually asked people online on Amazon Mechanical Turk to author specifically for one of the two personalities and like a certain mood that the robot was in at the moment. And we used this to build a more coherent personality for the robot over time. And what we've seen is, interestingly, the likability is not so much affected by the robot's personality. So both of them grow a bit from the first impression to after the game interaction. So again, here we only look at one game encounter. However, we see that for the perceived threat, the personality actually matters, because while for the optimistic personality, the perceived threat actually decreases over time, we see that for the impatient personality, it stays more on the same level. So when we look at the first impression, then the two robot personalities, they don't differ, obviously. People haven't seen it talking. After the social chat, it differs only a bit. There's no significant difference yet. But after the game interaction, for the first time, we find a significant difference between them. And that gives us a first indication that the way how the robot interacts actually matters and allows us to influence whether people overcome their threatening and uncanny feelings towards the robot or whether they don't. So just to wrap up, what does it mean now for our question, does a robot get rejected at first sight? Well, my research shows that uncanny impressions can actually change over time. So the first sight might not be the most interesting to actually study when it comes to long-term interactions that we want to have with the robots. And I think even more important is that we, as interaction designers, can actively influence this process by creating interactive experiences, personalities for robots, and strategies for the robot to interact that help people specifically to overcome their uncanny or uncertain feelings about the robots. However, we are not done yet, because there is still a lot left to do to develop proper design guidelines. And one of the very important things I believe that we really need to do as interaction designers is we need to get the robots out in the real world. We need to start looking at how people really interact with robots when they do not observe it in experimental design settings. We need to investigate more long-term interactions, and we also need to find behavioral measures that allow us to look at people's interactions with robots without asking them the same kind of questionnaires over and over again. So there's still a lot to do, but I think what's really important is that we understand how much it matters how we design our interactions of robots, and that just to focus on the appearance alone is not really what's going to tell us much about our long-term experiences with robots. Thank you so much, and now I'm happy to answer all your questions.